This is the first pre-lecture of the series. So what I expect you to do is look at all of this material before you come into the session in the computer cluster. There might occasionally be terms in here that you don't understand. Please note there's a wiki on the Blackboard site that will actually discuss some of these issues. So let's talk a little bit about C++ and let's compare it to C. And you may already have been taught some programming, and typically it's called programming in C in that case. But what you did was actually use a C++ compiler to write C. So how can that be? Well, there's a real issue there. There's the issue there that you can write C code, or at least a very close approximation, even if you use a C++ compiler. And that's clearly because C++ developed from C originally. So, since this course is on C++ and not on C, I insist you use the real C++ features. I will tell you, I will point out to you some of the features that you really need to know about, and make sure that you compare, and I will also compare those to what they would look like in a C environment occasionally, but will insist that you use the C++ style and as much of C++ 11, and I'll explain more later during the course what that means, as possible. So let's start by looking at a simple program, and it's a really simple program. It's a program that prints some output on the screen, namely C++ is the best programming language in 2015. Oops, made a mistake, I didn't change the calculation over there. The output clearly will be 2015 of this code. And as in all cases, all of these codes are actually available on the course website, or will be available on the course website for you to play with in case you want to figure out how they work or use them to build something else on. So they're all there. So there's a listing there, and essentially if you go to the course website you will be able to dig it out and play with that. So we'll go through what all of these statements mean in this code, and clearly there are quite a few statements in here that all require a little bit more explanation, and that we'll go through in a bit of detail. But first, let me show you what the same code would look like in C. And it looks rather different. You've got this hash defined statement in there. You still got an int main, which you had in the previous code as well, but then the output is done in a very different way, and it still will return 0, and we'll see that that's a very common feature of almost any piece of code we write. So this is how I don't want you to code. So let's analyze what happens with our simple C++ program. So what are the things I do want you to do? Well, there's a first line, int main, like that, which defines a very special function. So this is the statement to define functions in C and C++, and that function is called main, which according to the language standard must return an integer, which is why the function has been given the type int, and typing is discussed in the wiki if you don't remember what a typing is. So essentially it returns an integer as an argument. Some compilers allow for other types, for example Visual Studio 2.10. I'm not so sure about the 2.12 version we're going to use this year. If you can, don't. Okay, please refrain from doing so, because the language standard says it has to be an int. And the convention is that on successful execution the value 0 is returned. So that's why there's a return 0 at the end of the code. Typically, if it returns a 1 or a -1, that would probably indicate an error condition. The first line of the code started with a double slash and then some text over there which looks like a command, and it is a command, is a C++ command. Unlike the commands you may have seen in C, these commands do not need closing. They last for one line only, or actually they last for all the characters that come after the double slash and then essentially to the end of line. Which means you can also put them after some text, and essentially as long as they go on to the end of the line, it can be a command as well. So normal C commands start with a /* and end with a */. They can still be used in C++. Especially useful when a long command is required, which wouldn't fit on one line. In which case you can start it like this over there, end it like that over there, and keep typing, which can be quite useful because long commands can make a code much more understandable. The next line of the code after the command was actually a hash include, and these hashes have a special name. It's called a pragma, which actually says to include the file, which is usually present in a C++ program and allows routine and variables from the C++ I/O library, which is called IOStream, which is part of the C++ standard library. All of those concepts will be discussed in much more detail to be used. And we needed that because we wanted to print out a message to the screen which uses this thing called cout, this thing called endline, which are all parts, and even this operation over there, the insertion operator, which inserts some characters into a stream. We'll see what that means later on, and essentially gives me the output. Of course we can use C-style output. That's given if I use the pragma hash include C standard IO, and then you can use printf and all the other nonsense we're no longer supposed to use because we really want to use the cout syntax, the modern syntax. We also used another feature of C++, namely a namespace. You may already have seen this before, you probably have seen this before, using namespace standard. A namespace is like a container, a big bucket, in which the declaration of variables, arrays, functions and classes can all be placed. Now you can have another bucket where the same names are in there, and essentially they would then denote different objects. So that means you can use the same variable name in different namespaces, which avoid name clashing. Normally not very important, but in large programs it's crucial because often you do want to use the same name in these different contexts, different namespaces. The above namespace, namely namespace std, is for the C++ standard library, which is the one where cout and endline reside. If we did not do that, we would have to explicitly refer to cout as telling them in what namespace they are, which we do by prefixing the namespace by this std : stuff, which actually shows me where stuff is. So that tells the compiler that we are using cout and endline that are declared in the standard namespace. And we'll spend much more time on namespaces later on in the course. Now the line constant integer year curly bracket 2015 close curly bracket uses two new features which are specific to C++. The first one is the const qualifier, which forbids the value of the year to be changed once we have initialized it to 2015. In C, constants are usually done by the C preprocessor command #define. The problem with that is that is an untyped operation, so it doesn't tell me that year is actually an integer. It will make it a constant, but it makes it much more harder to work with. So we really would like to understand that year is an integer. So the second feature we have over there is that we initialize the constant as well, which is the brace notation, as it's called, C++11 brace initialization. The same method also applies to non-constant variables. For example, if you write int a brace a0 brace, that declares a new integer, initializes it to 0. Now this concept has changed rather drastically over the year over different versions of C++. In the previous C++ standard, which is called C++ 03, there's a form where you write a parenthesis 0 parenthesis, which might still be used in quite a few codes you see. I try to update all of my codes, but I can't guarantee I've done all of them. And there's even a third one, which is the one that's the C-style initialization, which is int a equals 0, which declares a new integer and initializes it to 0. We'll see later on that this third one actually is physically different. It really means it does something different than the first two do. I still would like you to stick to this form over here, essentially because this is the right one to use in modern compilers. So let's go a bit further than that, and let's look at how we declare variables. In C, in the real C, all variables have to be declared at the start of a function. In C++, declarations are only required before you use a constant or variable. So we've got the same first part of the code until about here, and then over here we suddenly declare a new constant variable, which is the mass of the sun in kilograms, which you only need to declare not at that point because it's used in the next line. Clearly I can't declare it after I've used it, but I can just declare it before I use it. But I have had executable statements that do something that act before that. So you want to know what the output is. The output is clearly as given at the bottom of this page. Now, printing. Output and input. We've already seen the method for printing because I've done it using cout and essentially using the insertion operator, which is a double less sign. And C++ interfaces with the I/O devices using some kind of abstract idea, which is called a stream. The stream connected to the standard output, which is usually your text window on your screen, sometimes called the terminal window, is called cout. The stream connected to the standard input, which is usually your keyboard but could be something different, is called cin. The streams and thus devices are accessed through two operators. The insertion operator, it's a double slash sign, which inserts data to a stream, and the extraction operator, which extracts data from a stream. And streams will be discussed in great detail in the next two sessions, not this week. So, just to show you how it works, a few more things about insertion. There's a special character in there which is called endLine, which if you insert it into a stream, ends a line. Duh, as Homer Simpson would say. So this would insert the string hello to the stream cout followed by a new line. There's an alternative to that which inserts the \n, so it's called an escaped n, which is one of the ways to denote a new line as well. So that will also give me an end of line, which produces the same result. There's often more than one way to do something in C++. Input from the keyboard, for example, you could do by declaring a variable int year, then say cin extract to year, and essentially that extracts the year from the input and essentially stores it into year, which is declared with a type integer. That operation can sometimes leave a new line character. Now it's not that important, but there are some examples, many examples where you see in C++ code, you see a statement like cin.ignore, and later on we may well need it. It's not necessary for what we're doing over here, but it's sometimes important if there's something left in the input because something went wrong with reading the input, as we'll see in a minute. So overkill is to do it every single line, but you can be smart and occasionally do it. I'll show you an example in a minute where it actually must be done. For example, if you want to check for bad input. So we now change our code to read the year from the computer screen. We extract the year from cin, but then that may go wrong. For example, somebody might type a, which is clearly not an integer. So what happens if I type A? Well, then what happens over there is that cin.fail, so essentially at that point cin fails, and we can use a while loop. We'll come back to while loops a little bit more, but that's just a loop that essentially keeps continuing as long as this is true. And it says cout, sorry your input was not valid, please enter a year. Then it clears the fail bit, because this is fail is set, so I need to tell cin that I've done that. I need to ignore the bad input, so this is where ignore becomes important, and read again. And I keep reading and reading and reading and reading until I'm done, and then I can do some output. And the output, if you for example were stupid enough to type the year in Roman numerals, MMXV, right, 2015 in Roman numerals, and what happens if you do that? You can test it yourself and explain why that happens. You get 1, 2, 3, 4 error messages, and then essentially if you then type 2015 after those error messages, you get sensible output. So can you explain why there's 4 rather than 1 error message? There's clearly only one set of incorrect input. Think about it. We may discuss that later on. So, we've looked at a few simple features of C++. I've really concentrated on some of the basic features, but I've already snuck in some more complicated concepts like while loops and stuff like that, but we mainly concentrated on input and output, and I do hope that we can have a chat about that later on.